So we're looking at just kind of putting all this together, general conics. If we've graphed these conic sections just by using what you know about the standard form of the equation, you can graph circles and sideways parabolas and things like that on your calculator. It's difficult because you have a function graphing calculator, and these are all relations, they're not functions. They don't pass the vertical line test. So what we do on here is, say I have an equation like x equals 3y squared, something like that. What we would do to graph x equals 3y squared is we would go ahead and solve this for y. We'd move the 3 over, so you have x over 3 equals y squared. Take the square root of each side, so y equals plus or minus the square root of x over 3. And so on your graphing calculator, you would type in the positive and negative version of that equation separately. And you could do the same thing for circles. And what the calculator will do is it'll graph the top half and the bottom half, or whatever order you put it in. So it would look like this. Just hit second. I've changed my, we were in polar form, so if you're going to do this with me, you can try it if you'd like, but you may need to make sure your mode is back in function. So you got to highlight function, hit enter, and then go to y equals. And then you just type in a second square root, and it's x divided by 3 in the parentheses. And then the other one would be second square root, oops, I need the negative version of it. So negative sign, and then second square root of x over 3. And then if you hit zoom and then Z standard number 6, it'll graph. I did it pretty quickly, but there's your sideways parabola. And that's how you would go about graphing circles, sideways parabolas, ellipses, and hyperbolas, is by solving the equation for y and getting the positive and the negative version of it, and then graphing them separately. Because as you can see here in color, that the y equals, this is y equals positive square root of x over 3, and then this one down here is the y equals negative square root of x over 3, and you put those two together and you have your sideways parabola. So that's the workaround. I don't know if you saw that at all last year, but that's how you would do it. Now, we do have, like, there's free graphing software like Desmos that will handle graphing all these relations. I would thought I'd show you that. So we're going to do a little bit of investigating on some of the, I'll call it the general equation for all conics, and see what happens as you change the coefficients around and stuff. So unfortunately, this isn't the best tool probably for looking at conics because it's a function graphing calculator, but you know, it'll work. You can make it work. So if we go over here, if you could log into, it's just Desmos graphing, so Desmos. Just Google it, and let's go ahead and play around with this. You have that sheet in front of you, but let's take that same x equals 3y squared and see if we can graph it in Desmos and see what it does. So type in x, and it's just drawing the line y equals x right now, but x equals, and we're going to type in y to the second power, and you can hit it. Shift and then hit shift and then the number, the 6, it's the little power button, and then square. There's probably other ways to do it, but there it is, x equals y squared. I can put a 3 out front here. So x equals 3y squared. And there's different ways to access the exponent here. If you click on the little icon down here on the bottom left, the keypad, you can also do powers in that way. So you just click on here, or squared. But x equals 3y squared. So it graphs it, it does fine, right? And so Desmos, in any computer graphing software, handles conics just fine. So that's really the way to graph conics with technology, is using something like this, okay? I think we even have, we may have we have some pretty high-powered. I think Mr. Orris actually, I'm purchasing it for him. It's called Maple software, so it's calculus-based, graphing, mathematical software too that'll do this. But there's all kinds of stuff out there. So if you look at your sheet there, and I think this is an easy one. Looks like this. Conic note, general form of a conic. Okay, general form of a conic. So this is section 5 in your book textbook, chapter 10. Let's go ahead and write down the general form of a conic, and then we're going to do a little bit of an investigation on here. General form of a conic would be this. It's ax to the second plus, there is a term called the xy term that has an effect on it, which we're going to investigate here with Desmos. It's bxy plus cy squared plus dx plus ey plus f equals 0. So we go through a good portion of the alphabet, at least what I know about. There we go. So there's the general equation of a conic. I had called the graphing form that we were working into the standard form. And this is called the general form. So that this is its form before you would go and complete the square and get it into the standard form so that you could graph it. Okay. But within this form, there are some rules, and I've included them on here. They're in your textbook as well. But I've included them on this sheet. Some rules that tell you, just looking at the equation in general form, what you could expect the shape to look like. Okay, you see that is a C. This is a, oh, that's a 0 on the end. It's covered up, is it? So that's the general form of a conic. Ax squared plus bxy plus cy squared. We've dealt, like the completing the square examples I did with the hyperbola and the circle. They had all this in here except the bxy term. Okay, so essentially I gave you equations where the bxy term was a 0. Okay, so it's not really as scary as it looks. It's, it's alphabet soup here. But we've seen equations with this. You just had numbers for all these capital letters in here, and you had a 0 in for b. That's it. So there are rules that say which shape this will be based on the relationships or values of a, b, c, d, e, and f. And it says excluding degenerate cases. So in the text where they talk about degenerate cases, the degenerate case would just be one in which it doesn't end up being one of those conics. Okay. So I thought we'd play around with Desmos just a little bit here and see if we can even find a degenerate case, find something that's of this form but ends up not being one of the 4 conic sections or slices of the cones we've talked about. See if we can happen across one. And just play around with these just a little bit. Just have some time to kind of think about it, play with it a little bit. And then see if we can apply that knowledge to just identifying what these are. And some of you may be able to do this already, but here on example 1, just being able to look at it in general form and with the coefficients and terms given, be able to tell me, well, when I complete the square, which standard form would I even be getting it into, because based on which shape it is. Okay, so that would be the goal, is to be able to tell, just looking at these, which shape it is, okay, in its general form, which is helpful when they're all mixed up. So, yeah, let's go ahead and play around with some of these on Desmos. So, kind of open-ended here, but I think, do you guys have a suggestion as to, let me put Desmos here, as to what I could do? Let's rewrite this. Let's go ahead and do one in that generic form that would create, can we create a circle? Create a circle. How about 3x to the second plus, what would have to happen for this to be a circle, do you think? Do you have to figure out circles yet in terms of coefficients in front of the x squared and y squared? Does it have to be a y squared? Do you know what the coefficient might be? Make it a circle. What would happen if, let's go 3y the second, and then we're going to add in some other terms, plus we need an x term, so we have a favorite coefficient. Throw in there. 10. Okay, so 10x plus, and then we need a y term. Let's do a coefficient somewhere between 1 and 10. So 6y, and then let's add on a term at the end here, maybe plus. Or maybe we could put in a, well, let's do it all plus, see what happens with all plus. How about a 9 equals 0, see if we can, oh, we created a circle. So in other words, with an A, B, C, or sorry, B is not in there, as you notice I left B out. An A, a C, a D, an E, and an F. All positive, and we did end up with a circle. It's centered over here. It looks like at negative, that's the point, negative 1.667, and then about negative 1. So there's a circle. What would happen if I change this, say, to a 9? What just happened there? What shape did I go from? I went from a circle to, that's an ellipse, yeah. So changing A and C to different numbers, okay, remember they were the same here, it was a circle, changing them to different values, maybe I could change it to a 2, changes it to an ellipse. Have any ideas on how I could change this? Can we try and change this into a hyperbola? What might change here to change this into a hyperbola? You'd have a negative in there somewhere, right? Oh, look at that. So it changes to a hyperbola, right? What would I do to change it to a hyperbola going maybe the other direction? Do you have any ideas of that? Let's try it. See if that works. Oh, there it is. So yeah. So you kind of start to get an idea of just changing one coefficient in that alphabet soup general equation, right? Can really change which conic section you have. It's kind of cool. And they generalize this for you. They lay it out very nicely in a textbook. I've tried to summarize it. And you don't need to memorize these rules, but it gives you an idea of what it might look like. Now, what do you think might happen? Let's go back to our original circle here. It's nice to have a place to go back to. But let's just see what happens if we put a bxy term in there. Let's just try one. Let's just type in the term xy and then put a plus sign on there and see what it does. So what did it do to that formerly circle? I don't know that we could call this a circle now. Do you see what it did to it? It's slanted. That's a good way to describe it. Yeah, it's a slanted one. I don't know that it's still a circle. I don't know that I have the rules memorized enough to be able to tell you, looking at the coefficients, whether it is actually one or not. Let's change it back to our ellipse that we had here. I like the 2 one. So there's an ellipse that is slanted. That's definitely an ellipse. We have different values here and here. And you can see that it's slanted. It's actually called, in the textbook, they call it a rotation of axes. And so what they're doing is taking this xy axis and actually rotating it through a certain number of degrees and then redrawing it. And there's a way to do that by changing the equation into polar form and finding a new set of axes and then graphing it. It's kind of complicated. We're not going to do that. But I would like you to understand that these conic sections in general form look like this, like what you see on the bar here. And by just slightly changing these coefficients, you can get the different shapes. What do you think it would take to change it into a parabola? We haven't got a parabola yet. Let's get rid of this xy term. Muddy the waters a bit. Any ideas on what I could do to make this into a parabola? Okay, so take the y. Let's just take it out here. Okay, that did it. Yeah. So there's an x squared. So that's a parabola. It ends up it's facing downward. You have to do the algebra to see why that is. Yeah, there's a parabola. Do you think you can make a sideways parabola out of it? Sideways parabola. Can we get rid of this? Which are sideways parabola. So there it is. So just a y squared in it. So what that tells me is that if A is 0 and C is not 0, I get a parabola. I mean, if I took made A and C in the general equation, or the number in front of the x squared and the number in front of the y squared, doesn't really matter what the letters are that represent those. now it's actually degenerated into something that is not a conic. Do you recognize that? It's a line. Does it make sense that that is a line? When I get rid of the squared terms and the xy term, I mean, all I have is an x and a y in there. So it's a linear function. It's an algebra 1 sort of linear function. So that would be an example of a degenerate case. If a and c are both 0, and then I can't remember the letters, but the numbers in front of the x and the numbers in front of the y are something other than 0. It looks like we have a line. You know, if I add in, let's see if I just do the xy equals 0. Everything else is gone, just xy equals 0. If there's xy equals 0, it's just a line right there on the x-axis, it looks like. So that would be a degenerate case. What would happen if I put in a y squared here? Plus that. So that's a degenerate case as well there. So there's all kinds of degenerate cases. See if you can find some other degenerate cases. Can anybody find one besides the non-trivial one where they're all zeros? Can you find one where it's not, something other than a line, and also not one of our 4 conic sections? Try it. I'm dozen this. See if you can somehow rewrite what we started with. 3x to the second plus 3y to the second. Whoops, I already did. Oops. There's something that's, if we zoom out here, does it show up? Where'd it go? Oops, I accidentally found it, I'm sorry. But there's an example of a degenerate case that's not a line. It's just disappeared, right? It's degenerated one day. It did nothing, make a point. There's nothing there. So, this might be saying there's no value, x and y, that would work to make this equal to 0 is what it's telling me. No real value. Real values. I don't know if you can get any other shapes. But can you find some of the degenerate cases using Desmos to figure out what it actually looks like and list them below? So could you list at least one degenerate case? Here's one. Could you list that as a degenerate case? Does it make sense, the degenerate case? It's just something that's not one of our conic sections. So even that linear one we could classify as a degenerate case. And this is the extreme version of it. This is a degenerate case in which we have not even a linear function. So there's one example of a degenerate case. You could maybe come up with one of just a linear too. All right. So looking at the conic sections down here, looking at the conic sections, I can get rid of this. Not ruin the punchline. Looking at A, B, and C there, can you tell me, just by looking at them, which of the conics would be represented there? I think you have a guess as to which one. What would A be, do you think? You think it's any guesses? Anything? Yes, no. D might be. Can you look at A and tell me what you think it is? How many of you think A might be a circle? Do you think it might be a circle? Anybody think it might be an ellipse? Ellipse. So it's okay. Anybody think it could be a hyperbola? Anybody problem? Yeah. Type it into Desmos. Try it. Type that into Desmos. 3x squared plus 6y squared plus 6y minus 12y equals 0. Type it into Desmos. See what you end up with. And I'd like you to write it down. See what it is. And then I'd like you to maybe make a guess on each of the next two, and then try it on Desmos and see if you're right. Just make a guess and then try it on Desmos and see. Trying to go through the alphabet and attach the correct variable with the correct power on it. But there it is. So, what'd you find on A? What was it? It was an ellipse. Okay. So A was an ellipse. What about B? Can you tell? Who's looking at it? What do you think? That's parabola. Yeah, I probably pretty familiar with that one. With y being squared and x being linear. It's parabola. And which way? Could you tell me, like, what type? Is it an up, down? You don't even have to tell me, like, specifically, but up, down, or right, left? So y squared. Yeah, so it'd be a right, left, like the one I started with in the beginning. Yeah, y is squared. If x were squared, it'd be an up, down here. So it's just kind of good to at least have an idea. Because then when you go through the completing the square process to graph it, you have an idea of what it looks like. What about this one right here? See, you have a guess as to what hyperbola. Okay, did you try it? And verified it? Okay. So there's a little summary just up above this, and really my goal would be that you could look at something like these three, and I could throw a circle in. Like if I change this 6 in part A to a 3, you would identify that as a circle. It's just good when they're all mixed up to know, and this will help on your test as well, when they're all mixed up, if you're going to complete the square, which form you're trying to get it into. It kind of presents itself as you group the x's and the y's, but it's good to know where you're headed. There's a little summary here, and it says excluding degenerate cases like the ones that we looked at where, well, and actually it's with the b equal to 0, so no xy term. So these rules only work when there's no xy term. When you throw a b not equal to 0 in there, it can change up what you might think on these as it rotates it. But excluding degenerate cases, the ones that end up being nothing, no solution, or something other than a conic, if a times c equals 0, so if a times c equals 0, so like in this case, a would be 0, and here c would be 1. 0 times 1 is 0. You get a parabola. Okay. If it defines an ellipse or perhaps a circle if AC is greater than 0. You have to look at the coefficients here, and if they're the same, then it's a circle as opposed to an ellipse. Remember, a circle is a special case of an ellipse, but if A times C is greater than 0, it's ellipse or circle, and if AC is less than 0, it's a hyperbola. So it's pretty straightforward and pretty simple. I mean, you could almost probably remember this for these until you bring the B term into it. It's pretty easy, right? The B term muddies the waters, and I'm not real familiar with, like, I don't know enough about conics to really have the rules memorized or understand all the little intricacies there. But interesting nonetheless. So there they are, those three. In terms of just because of time, we're running out of time. We're not going to go through these right now. Might come back to it next class, but you could go through. We have the skills to go through and complete the square and see that it would match up to one of these in standard form, and you could graph it here. We're not going to do that today. But I wanted to then go on to the BXY term here. I would like you, just for practice here, I would like you to graph these. Maybe we could do some of them together here. This one would be what? With radius 3. Yeah. So this one would graph that you go out 3 in each direction from the center and graph it. Let's just do these together. This one would be, do you recognize it in this form? Kind of relates to what I talked about in the beginning with the graphing calculator. Do you know what that would be? It is a parabola. It's a sideways one. Do you know what would it take to get it back into our standard graphing form? What would you have to do to reverse this process? What you'd have to do? How do you get rid of the radical? Square it. Yeah, so it'd be y squared equals, when you square this, it would just be 16 minus x squared. So, is it really going to be a parabola? So first, this was the parabola. It was kind of the form of this. But look at this. I got a squared here and a squared there. So is it really a parabola? It's starting to reveal itself, huh? If I move the x squared over, I've got x squared plus y squared equals 16. What it really is a circle, yeah. But it's just written in a funny form. And you could have written part A in that funny form. We would write it in that form if we wanted to graph it on a graphing calculator. We'd take positive version and the negative version. But because of the two things being squared after the first step, it is, in fact, a circle with radius 4. So there's our circle with radius 4. Now down here, C and D. Not quite in the standard form that I gave you, the vertex form. It's in the form you used last year. So, but if I move this over, x plus 3 equals 2y squared. That was the form you would have had it in. You're looking at it. Or this is the form that I had you put it in here this year. But that is a sideways parabola, right? Can you tell me what the vertex of that parabola is? Yeah, there's going to be a negative 3 in there. The negative 3 is paired with the x, so it would be negative 3, comma 0. And which way would it open? Right or left? It's going to open right. It will, because you have a positive coefficient from the y squared. And then if I wanted to be a little more accurate, could I find where it crosses through the y-axis? Do you think you could find where it is? Or how would you find where it crosses through the y-axis? What would x be equal to when it crosses the y-axis? 0. So you'd have to do this. It looks like this. So let's see. Can we do this? Is this very easy to do? Fairly easy. It's not coming out very nicely, but yeah, we could. So when x is 0, could you solve for y? So this would be 3 over 2 equals y squared, and so y equals plus or minus the square root of 3 over 2. So, you know, about what is 1 point something, right? Square root of 1.5 is going to be, you know, what is it? Somebody on your calculator real quickly, what's square root of 1.5? 1.2. Okay. So there it is, and then we have a negative 1.2. So we could quickly graph this sketch that. This one over here, how does this one differ? Yeah, it is. It's going in the opposite direction. And also I move the vertex in the opposite direction. So it's got a vertex of positive 5, 0, and then it's going to open. And we're not going to worry too much about where it goes through the y-axis. We're going to just quickly sketch it on the left. So, you know, you have to understand that these conic sections can come in all different forms here. Not just the standard form that I shared with you. As a matter of fact, you need to change it to a different form like I did in B, or like I did with the parabola in the beginning of the class, to be able to graph it on your function graphing calculator. And the question is, what does the xy term do to a conic? We're kind of running out of time here, but use Desmos, if you could, on these 3 to figure out the name of the following conics, if it even is a conic, and see if you find anything surprising. Like, look at A here. What would you guess A is? I should get a guess for each one of these before you do it. What would you think A might be? Looks like it might be a circle just based on the above stuff, but will it really be a circle? With this XY term being in here, it could change it. And then like this one looks like it might be an ellipse at first glance, but there's actually a little different set of rules here when you have the XY term involved. And so try each of these. It's like this one I would guess, well, I don't know, hard to guess. I mean, here you might guess ellipse because it's positive, positive, different coefficients, but one of these ends up being a hyperbola, believe it or not. And you can't really tell until you either graph it or complete the square with it. So try those three, and then let me know what you find out, and we'll wrap it up with that. Here you guys, yeah. Did you guys get all three of them? Did you figure out any surprises? What was the first one? It was a what? It was a hyperbola, yeah. So not what you would expect. What about B? B what? B? Here, what was it? That was the ellipse, and then what was C? That was a parabola. Okay. Isn't that interesting? So if you look at the rules on the bottom, as soon as you throw that b term in there, it totally changes things up. Do you guys recognize this b squared minus 4ac thing? Yeah. Where have you seen that before? Quadratic formula is what's under the radical in the quadratic formula. So with the b term in there, it's this expression that decides what shape it is, and it totally changes things up when you have the b term in there. So hang on to that worksheet. There's no homework associated with this. I just wanted to show you that there's a bit more than what you've seen up to this point involved with Conics section. So.